Okay, let's do a review of exponent, the laws of exponents here. Exponents, also known as the rules of exponents, the properties of exponents, the things you do with exponents. Okay, let's start with the first one. It's called the product rule, or property, or law, whatever you want to call it. So this just states, so if we have, x to the third times x to the eighth here, that we're just going to simply add those exponents. It becomes x to the 3 plus 8. We all know that as x to the 11th. You, of course, can write this using just letters. Let's switch colors here rapidly. We have x to the m times x to the t, and it becomes x to the m plus t. If that helps you to see it another way. Let's move on now. We know the next one is the quotient rule. Make sure we can see that. Is it better? No, it goes this way. Get it right. There we go. There we go. Sorry for the delay there. Let's move on. Quotient rule. See if I can spell it right today. That's the trick. So the opposite of this, if we have x to the 6th divided by x to the 2nd, this is the same as subtracting the exponent. So it's x to the 6th minus 2. We know that is x to the 4th. If you like to see this done with letters, well, let's switch to orange here. Let's say say I had x to the a divided by x to the f. This would be x to the a minus f. That's the rule. Okay, I hope I'm not going too fast. You can always pause. Let's move on next from there. So we have the zero quotient rule, the zero exponent rule. That is it's the shortest one here. Any exponent to the 0 power is 1. It doesn't matter if it's 88 to the 0 power, z to the 0 power. It doesn't matter if it's -4 to the 0 power. Notice the parentheses. That's really important. Okay. I'm not having luck today with the screens. Okay. All right, that's good. So that's the easy one. Let's move on here. Number 4, we have the power rule. So this is a big one we use all the time. So let's start the most basic example. I have x to the 3rd to the 4th power. What this happens here is we don't add them here. We end up multiplying them. This is x to the 3 times 4, also known as x to the 12th in this scenario. Okay, so we have that. We can look at this in a more simplified way with letters. This would be x to the a times b. Okay, moving on. And we have now some expanded power rules. These are just some variations. What happens. So let's talk about some variations of the power rule. This is number 5. We'll call this expanded power rule. Ooh, a lot of writing there. Okay, this just states that if we take things in a parentheses, so say I had, we have x and y inside the parentheses, and these were to squared. Notice that both the x gets squared and the y gets squared. We don't skip one. Also, let's switch colors here. Let's go red. It doesn't matter if it's in the denominator either. So let's look over here. We have 2x over 3y squared. I'm going to take everything here to the 3rd power. How do we deal with this? Well, we have to cube everything. The 2 gets cubed, the x gets cubed, the 3 on the denominator gets cubed, and the y here, it's power to a power, so we end up multiplying it, so it's 2 times 3. We get y to the 6th, and then we can clean it up here just a little bit. We get 8x cubed over 27y to the 6th. I think you can see that there, got a little chop, but that's all right. Let's move on now. So we've gotten through most of the rules. We just got the negative exponent rule next, so that's probably one of the more important ones here because it's easy to forget. Negative exponents. do not belong in the numerator or denominator. So let's say we had x to the minus 3. No, this is not proper. The same way proper grammar is required in English, this is bad grammar in mathematics. So we would put it like that. Same thing. Let's switch colors here. Let's go back to brown. If I had 1 over x to the negative 7th, again, this is bad grammar. Let's put a line here. This is simply x to the positive 7th. And the numerator, of course, the 1 is still there if you want to see it. And, this applies to, let's look at some more broad example of negative exponents. We have x squared over, say, y. And this is to the negative 3 power. Well, watch the trick with the negative. I get rid of the negative by flipping the denominator and the numerator. So if I put the y on top and the x squared on the bottom, guess what? This negative 3 becomes a positive 3. And then I can just distribute this. This becomes y cubed over x to the 6th. That's the general plan with exponents. Hopefully this review has been useful. Let's try some of those fun problems. I'll be sharing this worksheet with you. I've given you this worksheet many times, so hopefully it's not too much. Let's try a decent problem worthy of us. Let's try problem 17 from this worksheet. And it is going to look like this. It is 4x to the 5th y over 16x. Gotta make sure I look at just the right problem here. These can be confusing if you look at the wrong problem midway through. So let me just verify I wrote this correctly. Okay, I did. So in this case, I want to simplify this. Well, I have the answer on the worksheet I gave you, so I don't need to worry about that. But let's see what I can do. My job is to minimize the work inside. I want to pre-bus my table so I can cancel the 4 with the 16. And I just get a 4 on the bottom, yeah. This is canceled out, and 4 is left over. I can cancel, this is x to the 1st, so I can cancel it out with x to the 5th, and I just get x to the 4th on top. Over here, I have y to the 1st on top, and I have y to the 4th on the bottom, so I can cancel those out, and I get, I technically get y to the negative 3 to show an extra step. I can deal with that in a next step if I like to. There we go. So that becomes to the 3rd power still. Let's clean up, and we can move this negative 3 down, though, as we know. Let me just show that. Those of you doing this at home, maybe you don't need to show this step. You would just do it automatically, but I like to show it for those of us who want to make sure we see what happens all the time. All right. Now, everything now is to the 3rd power. So this becomes x to the 12th because it's 4 times 3. This becomes y to the 9th on the bottom, 3 times 3. And this becomes 4 to the 3rd. Easy thing to miss here. What's 4 to the 3rd power? You can grab a calculator. Luckily, I know what it is already. It's 64. But if you didn't know that, that's where your calculator's at. It's 4 times 4 times 4. And that's our final answer here. Let me just double check, make sure I get the same answer as the answer key. I did. Let's do a negative one with a negative value before we wrap up today. Looks like the hardest one there. Looks like we got a nasty one in 38. We're going to go to 38 here. Okay, we're going to look at this 38 here. So we have negative 2a 3 b squared, and we have c to the 0 power on the in the denominator. Pardon me. We have 3a squared, b cubed, c to the 7th, and all of this is to the negative 2 power. Yikes! What can I do though? I can do my pre-busing right away. So I can look at inside the parentheses. I can clean it up and say, okay, a to the 2nd, that cancels out a to the 3rd, and I come over here and I write it. What's left over? It's a to the 1st, because it's 3 minus 2. Okay, a to the 1st is left over. Good. What's left over? 2 minus 3, that's b to the negative 1, isn't it? If I cancel them out. So that's b to the negative 1, but I know that b to the negative 1, I can just write that as b to the first positively in the denominator, see? So I'm going to show that step there. And here I can do the same thing. This is c, 0 minus 7. Well, that's c to the negative 7th power, but I know that if I write that in the denominator, it becomes positive. Good. And my negative 2 and 3, these are both prime numbers. I can't do anything with them, so I'm going to just rewrite them. And my negative 2 is still here. It didn't go anywhere. Left myself some room. Let's keep going. Well, everything in, I believe, if I remember correctly, I can flip my denominator and my numerator, and that'll make my negative go away. Let's show that. Let's show red. So if I flip, let's take what's in the numerator and move it down below. We get negative 2a. I can write a to the first if you want to see it. And this on the top, we get 3b to the first. And we got c to the 7th. And guess what? My negative now becomes a positive 2, like magic. Let's now apply this square to everything. We get 3 squared times b squared, or 1 times 2, times c to the 14th, because it's 7 times 2. On the bottom, we get negative 2. We're going to be squaring that. That's important that we put it like that. And this a becomes squared, so let's clean it up. One last step. This becomes 9, because it's 3 squared, times b squared, times c to the 14th, over 4a squared. And let's hope you can do a drum roll. This is the correct answer we see for number 38. Ah, it is. Good. And how much time I'm running? I'm at 12 minutes. Oof. Let's do just one more here. I'll keep it quick. Let's do number 36. So we have, it is 5x squared times y times 2x fourth, y negative 3. And it's all here. So this is just another example we can practice. Well, let's look over here. We got the 2 and the 5 and the 2, pardon me. That just becomes a 10. I can get rid of that right away. I'll cancel them out as I go. Yoink, yoink. X to the 2nd times x to the 4th. That becomes x to the 6th because we add them. This is y to the 1st. I can show I'm doing it right. Y to the 1st times y to the negative 3rd. So we add those two. We get y to the negative. I cancel them out as I go to show I've done it. And we know this is bad grammar, so we can write this as 10x to the 6th power over y squared. And let's hope that's our answer for number 36. It is. Okay. That's a review of exponents. I'll be posting a retake for the exponent laws and this worksheet. Thank you and have a great day, Algebra 1.